I don't know. For some reason, I have my other class like Tuesday was not recorded, so I hope it's just my mistake. I hope it's not something because it was the first time like some. I mean, I had a lecture not recorded. So anyway, wait, there's a exclamation mark here. Was that for? Uh, but I see it's recording. Like okay, I guess that's fine. So okay. Um, what I'm going to do, like, okay, there's some echo from my other computer. Let me turn it off. Okay. Okay, what I'm going to do is just continue some of stuff that I didn't finish last time. It's very simple stuff. And then I will go back to have more OpenCV. And by the way, like, I guess if you guys are logged into Canvas and then maybe get a message from Canvas, I just posted an homework assignment, first homework assignment. It shouldn't be very difficult, but I give you a bit more time this time because I maybe some of you need to get familiar with Python and need to set up the environment and so on. So it's really an assignment on OpenCV, and you probably get like most idea what you're supposed to approach the problem like just from today's lecture. So okay, let's look at like okay, let's talk a bit of histogram. So the idea of like image histogram is like, I guess you know like what's histogram like from maybe some statistics class and yeah cell processing class. So histogram is just like I guess it's easier to explain just with this example here, right? So we look at histogram of like these two patches of image. Let's say I have a patch here. The histogram is correspond to something like this. Basically, it's just counting like how many pixels have what values because I basically for this image, this grayscale image, like the value is from 0 to 256, right? So it's saying like we have most pixels like about these values. I don't know, it's maybe 250 or around 250, probably correspond to this white uh shirt here, like no, I white cloth here, and cloth, I guess, and then like and then you see have some darker pixels. I have these distributions. Maybe it's around here. I have like two mode here. Maybe one is probably here. Maybe there's another mode. It's hard to say. I don't know. Water dark maybe around here. I don't know. So and also you see like for the face for her face here, there's a wide range, right? So again, I maybe uh, around the face you have this. This is like the that's basically the corresponding pixels is like here. So okay, very simple concept. So just want to mention histogram. So uh, I assume that everyone knows. Okay. So, but just in case if I'm still not making myself clear, like you can look at the pseudocode here. Actually, not even pseudocode. So MATLAB and Python, like let's say Python here is I just I will look through all the row and column for each of the pixels, and then I'm just look at the value of the pixels, right? The value, for example, look for the each of the pixel. I have the first pixel at value 0, then I will have the corresponding 0 coefficient of the histogram will added by 1. So I just say for which value will be added by 1 and so on. Okay, that's histogram, very simple, but that can be like some very practical use using histogram. For example, like I can do histogram equalization, like in this image here. Um, the original image does not have a very good contrast, so it is also reflected in the histogram. So you see, like it's have pretty level. Like it doesn't use a lots of the kind of basically the oops the entire entire range here. So what we can do is basically just stretch the histogram somehow. So that like if you look at like the histogram, like okay, this is a histogram by itself, and if I look at the CDF, the what's that called, cumulative like density function, then it have a shape like this, right? So if I make the cumulative density function like more linear, then it will spread this histogram, have a larger range, right? Can more efficiently utilize the entire uh, range here. Like, so then if I do that, then I will have like a better looking, like more high contrast image. So this is histogram equalization. Um, and also like to mention white balance. You probably don't even realize that, because I now like for cameras typically they have automatically automatic white balancing. So and if you look at like image like this, if you came across image like older image like this probably is like the white balance is off. So the entire image look like it's a little bit bluish, right? So probably the blue component is too high somehow. So you can do some white balancing, just shifting like the simplest one will be shifting the mean of that corresponding component. Um, so okay. By the way, like if I want, oh, okay, I guess it's a silly question. Maybe I'm not going to ask this. So if I, for example, like if I want to get more white balance here, apparently, okay, still I'm going to still ask it. So um, just in case. So um, let's say I have this image, right? I want from this image to this image here, I should decrease or increase the blue component here. When I say increase, I mean like I have all the blue component coefficient maybe added by a value, like maybe added by 10. I mean, that's what I mean by increase. If I mean decrease, I'm going to subtract the blue components. Okay, yeah, okay. At least like someone is here. Yeah, I think it's obvious. Like, yeah, because like this blue is too strong, right? So I should decrease that. So okay, that's just a slide. So, yeah, okay, it's not important. I'm saying like if you look for the camera for your camera, that's probably have an automatic white balancing. Um, and um, and yeah, so but it's also like and of course, if you have more sophisticated white balancing, it's like it will stretch a histogram itself of each of the component, not just like shift that component. But yeah, we are not going into detail for those. So what I'm going to do, like, we'll go back to OpenCV and play a little bit more Python and OpenCV. So last time, let's see, let me recall it, where do we end last time? So last time, what do we have? Maybe we have to do some plotting. Let's see, I think I mark it somewhere. Yes. Uh, okay. So let me start with like doing some image. Okay, I need to make a correction. So I do realize that anyway. Like, but I said that the newer version of OpenCV now use RGB color space, but actually it's wrong. Uh, I made a mistake because I look at my code. I thought I'm using OpenCV command and actually and I was not. So I tried it again yesterday or so. Like it's actually still using BGL component color space. Um, yeah. So it's just, yeah, but yeah, don't worry about that because let's see. Oh yeah, I need to pull your chat also like up here first. Let's wait a sec. Yeah. Uh, okay. So let's start with some more showing. So last time I plot this thing, right? Let's show an image. So let's say I have a random image. Let's say okay, that may be an interesting question also. Like this is I import like numpy. Let's say I matplotlib import pypod plt. Now let's generate an image like that. Very simple image. Let's say I have like numpy. Let's say I just call it maybe not. And it's okay. I guess that's I have a lot to talk about. Let's just forget it. So let's just say illustrate. Okay, I have this. If you know MATLAB or NumPy, like I is just the identity matrix. So therefore, like I am here is just something like that. Oh, actually, anyway, maybe I still ask that. Like if I'm going to show this image, what do you expect to see? What do you expect to see? Maybe I want to add a color map also. Like, actually, I don't need. Yeah, if I add the color map, I will have a black and white image, like grayscale image. So, what do you expect to see like here? It's a bit vague. Can you be more precise? Like, oh, you're trying that you got an error. Oh yeah, actually you got I got an error. Let's see why I got an error here. Let's see. Oh, okay. I'm sorry. Like I have typo here because I column map. So yeah, this I basically will have white square on the diagonal, right? Because I here just white square on the diagonal, and then back like in the. So I if I increase the resolution here, then I will get something more like a diagonal line here. Okay. So but yeah, basically an image is just a matrix, right? So a grayscale image. And I can make a color image like do something like that. So if I want to know that, like if I for a color image, it should be, let's see, I have let's look at the shape here. I can look at the shape of that thing. Say it's like this. So if I create a color image, maybe I call it CIM. I have like first make it 0 or 0. So I have the shape is like this, and then so therefore let me be like I just say it's explicitly 30, 30, and 3. And this of course it will be just all dark, but I can again maybe like I can have the first component is just a so what you expect to see would be like similar to this way, similar to what I had earlier, but by the way, what do you expect to see here now for if I do it now? So it's very similar to this. Hey, I would just say, okay, yeah. Oh, oops, oops. I want to make them together. Let me put them together. So yeah, for those who said web, maybe I'm not sure you actually. Oh yeah, it's yeah, you're right. It's web because um, that's I got confused also. So you note that here I'm not using OpenCV here because I PLT command here is from matplotlib. So matplotlib use RGB color space. So therefore, yeah, this is I will get a red line here. And so here, let's say I have OpenCV install, and maybe I just copy some of the code here instead of typing. So it's some boilerplate code. But you see, like this, the first 3 lines you're familiar with. Like I import open, just CV2 is OpenCV, and I have like matplotlib and also like NumPy. This one is something new. I want to load an image because I want to read an image. So here let's load a very popular image linear, like amount image processing people. So let's see if I have okay, let's because you don't have that now, so let's read that like as online. So I use a IO command. Okay, by the way, like I just want to show this error message here. For you guys that you probably came across this error message, this is the time you probably want to Google that. So this is actually related to I don't have the scikit-learn. Sorry, not scikit-learn, scikit image package. So if you Google that, okay, yeah, I should just install that. So let's pit install that. How to spell that? I have super short memory. Let's see if I copy. Oh, I did. No, I didn't. Scikit image. Okay. So now if I after installing that, so now I should be able to. I have some warning, but I able to load the image. You see, like I'm loading directly from online. This is pretty nice, and I can like let's show that again. So this is a linear image. Now let me write the file. Let me write it into a oh, wait a sec. Yeah, that's fine. Oh, okay. If let's call, yeah, I have this file name here. I already used the file name here. Write the file cv2. By the way, if I use cv2, like you probably can use IO to write also, but here I like to demonstrate using cv2 to write the file. But be careful, if I use cv2 to write the file, I need to change the color space because I mentioned that like is cv2 assume a BGR color space, but this image when I read it is like RGB, right? So I need to first convert it to like BGR. So I use this command cv2 cvtColor, that have the image. There's lots of like lots of possible conversion. It's not just like RGB or like to BGR, but also like you can convert to HSV color space as we mentioned last time. Actually, you will need HSV color space for your homework. And color RGB to BGR. So then, of course, doing the same thing, but I have this is actually saved to RGB, so I can see if like actually it's really here. Right, I have the file here, and maybe I can open it from somewhere else, so just to make sure. Let's see. Actually, maybe I just open the term. Oops. Yeah. Open the terminal here. So you see, like it's saved correctly. So if I don't do the conversion, then I will get something. Of course I can save it also. Right? If I don't have the conversion, I will save it also. But the problem is, now if I guess probably the image is still there. I don't know. Yeah, it's already automatically update. So, but then you see like the color is totally off. Actually, it looked completely blue because the original image is pretty wet. So like it's the wet component become the blue component. So actually, whenever you see something like that, most likely it's just that you don't use the correct color space because OpenCV assume like RGB. So let me do this again. Now I have this the correct color space here, and now let me do the similar things to read the file. So I can switch to image read now. I read the same image here. Now, if I use image show here, so do you expect I get correct color or incorrect color here? Yes, it won't be correct. Okay, so because the image is stored like correctly using OpenCV, but when I read the image, right, I assume BGR class space, and PLT like using like matplotlib is assuming RGB class space. If I just show it, then again it will be like the color will be off. So to do it correctly, of course, I can call it back to what's that command? cv2 convert color the image, and then cv2 color BGR to RGB. Now it will be correct now. And by the way, like of course, what this command is doing is actually just flipping the basically the components, right? So for example, like if I read this image here, I call it let's see, maybe I call it this image again. With this file, I call it image. Now if I don't convert it, I just show it now again. Of course, something is off now, but I basically maybe I say a new image. It's just image numpy seals like image. So this command is just generate some empty I mean, Osseo's tensor or that have the same dimension as the argument. So if I, for example, like if I here, like just verify that I should get all dark image here. So, but if I have like image, okay, maybe like this is maybe a question also. So what should this number here if I want to convert to what should be the question mark if I want to convert to from BGL to RGB color space? Oh, sorry, I have a typo here. It cannot be. Yeah, thank you for pointing that out. Yes, right. So I have the blue and the red component should be swapped. So therefore, like the original red component is in the third one, right? The index third one, I mean index 2. So now I can swap to like index 0 or like move it to index 0. So if I do this, so it should get me something like okay. So it's basically like of course yeah, you can use that command, it's a bit quicker, but like underlying is doing nothing, but it's just swapping that. And let's see what I can play directly with this image. So by the way, like you see this command is very similar to MATLAB, right? So I just say actually I didn't explain it earlier. This is like I consider all the just all elements that for the first index. I ignore all yeah, how should I say it? Like for the first argument, I will just take I should say like I take all the elements with the first argument is equal to 0, right? And colon is like it's matching everything basically. Um, and I can I can just maybe like I don't know, make some maybe just for example, let's see. What do you expect if I do that? Like yes, you will see something like it's black, right? Around somewhere here. Actually, a small square. It's a 20, 40. Oops. Yeah, I will it will be blocked. So it'll be like somewhere here. Yeah, I cannot point it out. Yeah, so I have a square somewhere here, right? So back to square. And okay, let's see. Now let's do some video capture. So I will again I list 3 2 and then I maybe also numpy already import that. Okay, let me type it anyway. Now let's see. Let's just do some very simple capture here. So for So OpenCV capture, you need to use this video capture command here. So I have a video capture, just create a kind of like a object like to capture things. Oh, by the way, like typically this will be zero. Like here, I have multiple webcam. My laptop have a webcam. I have another webcam here. So therefore, like but typically this will be zero. And I don't know why I have two here. Like I would think that it would be one, but if you plug in like two webcams, and you may want to, if you want to access to the second webcam, you may try different numbers here. It may not be one. Maybe like myself here, like in this case, it's two. So I can call this cap, let's say. And by the way, I can set the size of these things here. That will be like 3 is the width, or like I can, if I don't remember that, it's a no, it won't work. You need to put in a webcam, or like if your laptop already have a webcam. So most like more newer laptop will have webcam, right? Or like um uh but if you don't have a webcam, then it won't work. So or like you can get a very old webcam like to play with as well. Um if there's one webcam, most likely the value will be zero. Um and I can set the, yeah, I don't know why. Yeah, it's okay. Let me define a W size here. W size maybe 320 to, I can make it bigger actually, 480, let's say. And actually this is not needed, but I put it here anyway. If you want to change the capture height. And so let's try to capture frames. So I have frame is equal to cap read. So let me give a return here also. So if you do something correctly, you will have like return is equal to true, and then you have the frame is a oops. I guess I need to move something. Maybe let's see. Maybe I just put my cam here. Let's do it again. Oh, okay. I have to release it. Okay. So let me put a release here. So I ran out of this error because when I run this code again, like it tried to access the camera, but I didn't release the camera, so therefore it came I mean earlier, so it came out of error. So now it should have, wait, yeah, it should work. So yeah, the color is off here because yeah, I will take the time. Yeah, yeah, my room is like very messy. I will, yeah, I try to hide from the camera as well. So but yeah, sure I can. Yeah, it's like, wait. Uh, and yeah. So and of course I want to kind of capture like, I mean usually you want to capture like a continuous stream. So typically what you're going to do is I have a create a while loop here. And this is pretty standard. So, and then I can have the while loop and then I keep seeing the showing the, so instead of like using like a PLT show, I can use cv2 show, then we'll actually the color will be correct. But I need to create a Windows first. Let's see. For that, I can actually it's not really very important, but maybe I put a window name outside. I call this camera. So this will be an identifier for your window as well. I mean for your for the, so and then I can capture the frame. So let's see. I don't want to run it yet because I want to make sure it can be break gracefully. So typically you can put a wait key here. This will be like a millisecond or something. It will keep I think it's like how much frame rate here that you're going to record the video. So the smaller the number, you will kind of like have more what's that, like you will record more frequently. I mean, you will capture frames more frequently. And okay, this should work. So basically, if I do that, wait a sec, maybe it's not really COXR, or I have a typo, it's not over here. Wait a sec. Series 2 image frame. Okay, I guess I probably like, okay, when again. So now it's working. So it's basically, oh yeah, I'm not sure I should show my, it's so messy that like, yeah, I have a tendency not to, I'm not sure, but that's my another cat. And he's foxy and very, at this moment is very quiet. Yeah. And so by the way, like, okay, just for okay, I want to hide from the camera, but maybe I cannot if I want to show this. If you have two webcams, like what I'm doing, like plug in one webcam, and I have my laptop have another webcam, you can try to like access both webcams actually. So let's say I have this webcam is a first webcam. I have like cam 2, let's say, capture 2, video capture 0. So this will be my laptop webcam. And I would like to set the width and height also like later on. Return, you mean here? Oh, that's nothing. It's not a command. It's just a, you want this command here. It will return like two values. The first value is just a saying like whether it's successful or not. So when RET is true, you'll be successful. But by the way, like if it's not successful, then like the frame will be empty as well. So like so usually I don't bother to check this guy here because like if it's not successful, you will realize that basically. But okay, so I can, let's say I can capture 2 frames here. I use the same, but I call it this, maybe I give a different name for that. To read. Now let me create a new frame here that put them side by side. So let's see, I call a new frame here. Let's just first resize them, because my 2 webcam have different resolutions. The image that I mean the frame that capture may not have the same size, so I like to resize that. I mean, it's kind of weird that even you set this size here, it may still not the same size. Yeah. Uh, it, wait, let me run this again. Let's see. Probably I want to, wait, is that hiding somewhere? Yeah. So here it doesn't have any problem because I now it's like both of my command is using BGL out BGL color space because I using OpenCV to capture is using assuming BGL color space, and also I'm using CV2 to do image show. If you use a PLT like a matplotlib to show image, then you need to change the color space back to RGB. So let me make sure I quit this. Yeah, did I quit that? Wait. Oh, okay, I don't know why it's let me false Q. That's one against okay. Yeah, okay. Did I have a typo somewhere? I think it should. Oh wait. Let's force it first. Okay, so it may have something to do. Oops, the kernel die. So let's restart the kernel. Yeah, I suspect that it may have something to do. I haven't completed all the codes because here I have accessed like this cap2 here. I have cap2 release. Let's see if that will. It's weird. I don't know like why it doesn't quit gracefully. So when I press Q, I just press Q basically. I press Q, it should just break and release, right? But it kind of seems like it's kind of hanged here. Okay. I I'm not 100% sure. Maybe. Let me try to run my other. See if I. Oh, I don't have any problem like on my other. So, but anyway, let me continue first. This is not a major issue anyway. It's just not breaking gracefully. So let me get that image. And then what I'm saying like is like let me just put two frames together, and by the way, like there's one thing that even I set the width and height here, the frame may not get exactly the width of height you chosen. Like I don't know why, but it just doesn't. So then therefore like if I want to put them two together, I want to concatenate them, I need to make them the same size. So I can use like because I can just use a let's see, CV2 have a resize command. So I resize the frame with this W size here, and also yes, because your video okay, because you have a capture error. So you take a look of your return value here. Most likely your return value is false. So basically like um either your webcam is not connected or like some other application is using your webcam. So if, in that case, you need to turn off your webcam. maybe you turn on the webcam like for Zoom, you didn't realize that. Yeah. Yeah. So and I can concatenate them. Let's see, concatenate. Use a numpy concatenate. I call this a new frame. Let's see. I have a new frame like that. So, actually, it works even right away. So, I try to hide from the camera, as you see, because I have a really hippie nose, looks now, really super long hair. So anyway, so this work, and I don't know, like still like Q is not working well for some reason. Let's break this. Let me copy my code that I. Oh, okay. I don't have destroy all window here because okay. Yeah, release destroy all windows. That will be, I guess this time will be ending gracefully. And when I concatenate, by the way, like I concatenate them by default is I concatenate with the zero zero index. So if I want to put them like side by side, I can set concatenate them with one index one here instead. So then it should get it side by side, I guess. Yeah, something like this. So now it's, yeah, now I press Q, it's just I release it gracefully as I have this destroy all windows here. And by the way, like you may come across a problem like let's see. I'm quite surprised that like I don't need to set the size because when I did last time I have error that cannot show what I mean like and I Google online like basically it's my bandwidth may not be sufficient. So if you have two webcams, I'm like to play with that and you came with errors that return and return two, one of them is not true, then most likely like you have a bandwidth limited bandwidth USB bandwidth like for your webcam. So then in that case I can set this thing here to reduce the bandwidth of your capture, then capture frame. I don't know why it suddenly become that kernel. Like my kernel keep dying. Let me restart it. Okay. Remember to add this. Yeah. I forgot to add this also. Therefore, it does not close the window and it hangs. Basically, you have released everything. Like then the Windows like it's still there, but it's supposed to get response from for Python. Like you're trying to refresh the window, but it didn't send any other message. It just hangs there. Therefore, so make sure you have this here. Then it should end gracefully. So okay, there's some video capture, and so let's show not the new frame. Let's show just show the frame. I have a typo here. I guess I have a typo here. I probably need to run again. Wait. And frame. Huh. This time it's not captured correctly. That's so weird. Okay, let me block it out again. I think either my frame or let's see. Return is okay. Return to is yeah, I have one of the camera now. It's not. Yeah, this is a. This is kind of like if you don't only play with one webcam, probably you're okay. But this is a suddenly my other webcam is not doesn't like to work with me somehow. So okay, let's forget it. Let's forget it, and let's just use one webcam here. Oops, let's comment this guy. Let's get back to the original code here. Just showing one frame. Still like complaining. Why? Let me restart the kernel here. Okay, so restart the kernel, solve the issue, and now let's try to still let's see. Let's put some text on the image. So because that will be needed for your third part of your homework assignment. So to put in some text, I need to define the font. Is that how to pronounce that font? And let's see. The font is like that. The font scale 0.5, let's say. And I can have color, put in the color here. And thickness. So did you work early or like it work and then suddenly it doesn't work? If it work and suddenly it doesn't work, like you may try to restart the kernel, maybe solve the problem. It's just like what I did earlier. Yeah. So and let's put test. So I have the frame. I capture the frame here, right? So how OpenCV work is pretty simple. Like you have the frame. You want to show that frame. For example, what I did earlier is I just put two frames together to build a new matrix, or like actually a new tensor, because it's like with height multiplied by three components, color components there, then show that way. So if I have to put test commands, basically just on the frame, I change the corresponding pixel. For example, I have the frame here. Is CV2 put test frame and OpenCV. Or like you can pick something out. Like maybe I put Hello World here. Hello World. And where I'm going to put that, like the location 1010, let's say, just try it. How does that work? The font and then the font scale, color, thickness, and CV2 line. I don't know what's the last one stand for, but anyway, somehow I put the hello world here. So the location 1010, I may move down a little bit. Maybe I put it 30. Okay, I didn't quit it yet. Okay, now it's okay. So, and I can increase the size and so on and so forth. So, by the way, let's see. By the way, let's try to convert to like HSV space as as I mentioned, in your homework you need to convert to HSV space. So if I convert to HSV space, I say I have like let's say frame is equal to CV2 cvtColor frame like CV2 dot color BGR to HSV. So now this will get into HSV space. It will look quite weird. So let's see. How does that look? So it looks very weird because now it's HSV space, and it will assume the H component is blue component, right? So therefore it's quite weird. But if I look at maybe the image, like per frame, like let's say I have frame here. Let's see, look at one frame here. Okay, right. Look at one frame here. Let's say I can just look at the H component. So this will be the H component. And maybe let's use the black and white color map that will look a little bit more pleasant, I guess. And you can also like look at the SMV. This is the S and V. V basically is the luminance, right? So it will just convert to a black and white image, basically, if you just look at the V component there. And there are lots of like color conversion option that is available. So you can look for that. For example, I look at CV2. You have like lots of like options, right? I can just look for options that that start with color conversion. So maybe I can look for like just take a list. Let's say command list for command in this if command starts with color. Oops. Yeah. So then you have basically all this possible color conversion. And by the way, like maybe one more thing is it's not really related to OpenCV, but it's kind of cool in Jupyter. Let's say I want to see like what's I have HSV color space. Let's see if if you remember like what's the HSV color space looks like, right? HSV color space. So for different hue value, like S and V is like corresponding like okay, how saturated will be like how colorful is that color, and also value is the brightness, right? So if I I mean, just for convenience, let me define a command. I say, like show color. Let's say I have show color. Okay, let me give a values here. It's just a value. No, HSV, the hue, like given the hue. So I'm going to show a pixel. Okay, maybe I should do it like that first. I will generate a pixel with let's see HSV, yeah, H, and the S and V value. I would just say set S and value to maximum. So but note that of course like this is not in HSV color space yet. This is assuming BGR RGB color space, right? So I would like to convert this. So this is an HSV. Now convert to RGB. Let's say I have CV2 cvtColor this pixel. Oh, that's okay, and cv2 color HSV to RGB. Let's see. Now, if I want to show color, let's say I try a value like 5, let's say, that's correspond to showing a color of color patch of like H with like value 5 and then S and V with value 255 and 255. So I can try something else like for different H values. And by the way, one thing, as I mentioned, like really nice about Jupyter is I can do something interactive. I can have like a IPy widget, import interact. Now I can interact with this function here. This function show color, and the values, I say H is say from 0 to 255. I have a typo here probably. From, yeah. Now then I can play with that, like, okay, just changing, see how different H values is correspond to different color. So in your homework assignment, I asked you to, I think it's a, find all the blue pixels in the image. So that range around, I just say approximately like 90. Yeah, it still looks blue to me. I don't know. Maybe different people have different. This doesn't look blue to me. And maybe 90 to like 120 or somewhere like that. Like, okay, I gave a value like in the homework assignment. So you are supposed to look for all the pixels with that value. Yeah, you don't want to use a loop to do that. Like you can look for a numpy command. Yeah, I will let you explore that like a little bit yourself, I guess. But any questions? Like for that's basically everything for now. Like for OpenCV, and it takes quite a bit more time than I thought. Uh, so and I don't know. Like I have 10, 12 minutes. Uh, yeah, sure. Like you can install Python 3.7. Yeah. Um, yeah, you can just pick install. Like it should work. Like yeah. Yeah, you should do a screenshot of running that thing that you have. Uh, I you you just need to have a screenshot of like you running your code, and also like your code itself. Like your code itself, like you just you can just copy paste, say like here, like just copy into uh your Word document or something, like whatever things you use, and then afterward you convert to PDF for submission. Yeah. So and you can take a screenshot, like put the image there, and then like copy the code like that. Yeah. So um that's basically, yeah, that's basically it. PLT is not defined because you didn't import that. Like you should have this import command, like from matplotlib import like py plot as PLT. Yeah. So okay. So I will have 10 minutes. This is a little bit I don't know, like, but okay, I will start with my other set of slides anyway. So next thing the next thing I like to talk about is filter. So let's see. Oh, wait a sec. Like again, I need to pull your chat box down. So so filters a very simple concept. So it's like just you yeah, maybe I just have this. So I have think of like your image itself is just a two-dimensional objects, right? So okay, considering you are kind of like processing one component at a time, so I can pull out a red and then blue component and green component and process them separately, or you simply have like a grayscale image as input, so then it's simply a matrix. Then I'm going to process that like with some system filters, like whatever you think of that. I'm getting new image there. So you maybe it's better to get an example. Let's see. Maybe I get to an example first. So for example, like I have a filter like this, like simple like a box filter box. Yeah. That it's just like taking average of like 9 labeling or like 8 labeling pixels, including itself. So then like when I take this filter, it's just like, for example, if I processing this pixel here and look at the all these labels, pixels, I'm just take this patch. You can imagine is I just take this patch and do a kind of dot product with this patch here. So and then therefore like this guy is 0, and then I get this one like this whole thing, do a dot product of this guy. So I will have like 10, then have 20, and so on and so forth. Um, and oh yeah, by the way, like this is a very probably just check your understanding. What do you expect the value here? So the filter is this guy. So I am basically this patch here doing dot product with this filter here, filter here. Yeah, you should just say this would be just equal to this 90 multiplied by okay, or like over 9, and then 0 over 9, 90 over 9 plus 0 over 9 plus 90 over 9, and so on and so forth, right? So therefore it should be just equal to 50, and so on. This would be 90. So then like you do a anti-filter would be like have a something like kind of like an effect like this. And let's go back to the slides like why we want to study filters. Like there's several like obvious application, like you can do denoising, like very simple denoising, like nothing sophisticated, but it will be very effective. For example, like to get rid of like salt and pepper noise like this. Kind of super resolution. Of course, it's not state of the art. Like and you can do in painting like this. Like so-called in painting is that you have something you want to get rid of from the image. Um, and uh, and this is just repeating the last slide. So uh, you can enhance image. Also, like you can also extract features from the image, like texture, edges, and so on. And also like can do like template matching, template kind of like detect a pattern in the image. That would be like that kind of match filters, right? Basically, for example, like if I have an image here, I want to match with this a patch here. So I will just have this patch as the filter and just like go through the entire image. And then the one have maximum value will basically my match. So let's continue. We have the box filter I just mentioned earlier. So it's just a smoothing effect where you smooth the image basically. Um, and by the way, like yeah, this we wanted to sum it to one, right? Why we want to sum this filter? Typically, we want to we want the value of the filter sum to one. Just you want to have the energy kind of conserved way, that more or less have the same brightness after doing the filtering. So yeah, this is a box filter example again. And okay, this is a, a number of, what should I say, example again. No, I probably shouldn't ask all of them, so that would be like too much. So this one, like, okay, maybe I ask this anyway. What do you expect to see here? This one, like, if I have a filter of this apply on this image, yeah, that won't be any change, right? So like, uh, and so I think you guys need to answer very quickly now. So, and how about this one? Yeah, so it will be shifted by 1 pixel, right? So, and I don't know this. Oh yeah, okay, I will just show that. So it's okay. So this what you get is a maybe a kind of a linear filters, right? So you see like the effect here is if you look at the filter here, so horizontal, okay, look at this vertically. Vertically is like you have 1, 2, 1 here, and this one is -1, 2, -1 here. Um, okay, maybe. So what you can think of like this is when you uh, look at just this direction. Okay, look at the vertical direction here. 1, 2, 1 is equal to 1, 2, 1 multiplied by 1. And I have -1, -2, -1 is equal to 1, 2, 1 multiplied by -1. So in terms of the vertical coefficient, the effect is like the same as just applying 1D filter of 1, 2, 1. And the 1D filter of 1, 2, 1 is actually just doing an averaging, right? So it's like, again, it's like kind of smoothing. In the vertical direction will be smoothing. And on the other hand, like if you look at the horizontal direction, like 1, 0, -1, 2, 0, -2, 1, 0, -1, they all will be like kind of like a what should I say? Exact opposite of smoothing, because you are, if you have going to an edge, basically you can think of this is actually on the horizontal direction. In the horizontal direction, it will be doing a edge detection really, because it's detecting like transition. Like think of like hmm, maybe it's better to uh, oops, I think I didn't have my yeah, I probably then have to come back anyway next time. So so what I mean is like my horizontal vertical. Oh, okay, yeah, I need to restart soon. I don't know why it's not detecting my. Oh, I'm running out of time. I guess that's fine. So okay. Anyway, I guess I probably will just come back next time. Um, and to talk more about filters. So I guess we'll just end here, and then like yeah. Yeah, I will end the meeting unless you have questions, but I will probably wait for 5 minutes in case you guys have questions. So yeah, sure. Yeah.
Dr. Sam,
Yeah. Yes.
can you hear me?
Yes.
So I was wondering how this filter only filtered out the edges. Uh, I cannot uh, understand it.
Yeah. Okay. We'll be come back to that because I went out of time, but I will come back of that like next time. But the quick answer is like you think of like vertically, it's actually you have a low pass filter, and then horizontal you have a high pass filter. So vertically it's smoothing out the pixels in that direction, but horizontally it's like trying to your high pass filter will look for edges basically. So therefore, like eventually you would only look for vertical edges. Yeah.
So high pass filter is used to find the edges.
No, low pass will smooth the pixels. So therefore, like if vertically it is moving the pixels, right? So therefore, like it won't catch any edges. So therefore, in this case, it won't catch any horizontal edges. It only catch the vertical edges because like it's the horizontal direction. So okay, know that like, it's the horizontal direction is the high pass. So therefore, it catches the vertical edges. Yeah,
Hmm. Okay. Okay, maybe
yeah,
it will be more clear in the next class.
yeah, but yeah, I will repeat that like next time. Yeah,
Okay.
yes,
Okay. Thank you.
that's sure. The CV2 CV2 cvtColor. Uh, Let me close this thing here. So there's lots of options like this color here. Uh, so the argument is that you have this whatever input image, then you want to convert the color space, right? So this is a starting color space. So if I use OpenCV to capture, then it's like BGL color space, right? Then maybe here in this case I want to convert to HSV, but maybe like if I want to convert to RGB for other applications like or other packages, then this will be like BGL to RGB. And there are lots of like options there that you can choose. And actually, I think I have a command here somewhere, so I don't know whether it's still here. Yeah, so for example, like here I list all the members of like CV2 that start with like color. So then like if you look at the list, like there's like many of them like options here. I'm not sure I answer your question basically. So basically, the first argument of the CVT color is the input image, and then the second argument is the options that choose from which color space convert to which color space. Did I answer your question? I guess. So so color example where that is a which one show color? Okay, this one. Yeah, I have a show color here. Yes. Can you want this guy here? Okay, most likely it's the bracket. Be very careful with the bracket. I have three brackets here because this is actually a single pixel image. If I look at this guy here, oh, okay, I don't have anything. For example, like if I put a seal here, I have this like three brackets. Uh, you can think of really is a single pixel because it is a three-dimensional object that with height is one, width is one, but you have three color components, and the three color components is like 255 and 255. So yeah, I think most likely you have these bracket errors because Yeah, that's you need to feedback us 3 square brackets here, and then you convert. Yeah, and also like there's lots of bracket. You need to be careful. Yeah. So do you still have that error? Oh, you still have the error. So let's write it into couple steps, then it'll be easier. So let's say I have a image called just this like numpy integer a. Now with the 3 square bracket here, 255 and 255. Yeah, let me know if like you still have error with this, and you want to test it like right away. Also like this, show color. Let's say 1. Do you have that? Or even split it further, so that will I can have like image equal to this guy, and then image show. So do you still have that problem? Okay, yeah, it's likely like the backup problem. So okay. So do you guys still have any problems? Questions? If not, I most likely will kind of like, yeah, sure. I will. Oh, yeah, I will break the connection now. Yeah. See.